prove the Kelvin's generation of Green's theorem, that is, integration of w del u dot product with del v dv equals to the integration of u w del v dot product with n vector ds minus the integration of u del dot w del v dv. So we need to show this result, and also further we need to show this. How to get this from this? Just interchange u with v, right? And then we get this result. And to prove the result, I'm going to use the right hand side first, and from here I'm going to prove this left hand side. Alright, before starting with the proof, let's read this remark. It is important. The divergence of u w del v, this is equal to, just take this one and this the second. So this is u w and then the divergence of del v plus del u w dot product with del v. So we need to use this result also. Let's start with the proof. So writing the right hand side first, because I'm having the dot product of this with n vector ds. So I can use here Gauss's divergence theorem. That is the integral of divergence of this vector dv, right? So let's use the Gauss's divergence theorem over here. So this is equal to the integral of the divergence of this dv minus writing the second term as it is. And in the bracket just write using the Gauss's divergence theorem. Integral sign the divergence of u w del v. What is this? We are going to use this result now. So this is u w divergence of del v plus del u w dot product with del v. So this is u w divergence of del v plus del u w dot product with del v. It is very easy to remember. Writing here dv minus the integral sign u. Okay, this can be written as divergence of w del v. So this is divergence of w del v dv. And in the next step we are going to apply the same result over here, the divergence of w del v, right? So writing the first integral as it is minus the second integral u into, we need to get the divergence of w del v. Let's apply the same result over here also. So writing here w divergence of del v plus del w dot product with del v, and writing here dv. Is it okay? Fine. Alright. Let's merge these two integrals together. We get u w divergence of del v plus del u w dot product with del v minus u w divergence of del v minus u del w dot product with del v dv. So cancelling these two, this is having the negative sign. So we are having the integral of del u w dot product with del v minus u del w dot product with del v dv, right? I can write del u w to be as grad u w, that is the gradient of u w. Similarly, del v can also be written as grad v, and here also del w can be written as grad w, and it is also written as grad v. So let's write in terms of gradient. Very fine. Okay. So this is the integral of grad u w is what? It is u grad w plus w grad u. Yes. And having its dot product with grad v minus writing the second term as it is. Let's take the dot product of grad v inside. So this is u grad w dot product with grad v plus w grad u dot product with grad v minus u grad w dot product with grad v dv. So this is cancelled out with this and we are lefting up with the second term only. So this is equal to the integral of w grad u dot product with grad v dv. Yes. So further it can be written as w, okay, writing grad u as del u dot product with del v, right? This is what is needed to be proof. Yes. We have started from the right hand side and we have reached the left hand side, right? To get the second result, just interchange u and v together. So let's interchange u and v. We get the second result. Let's write the left hand side first. Okay, what is the left hand side? It is the integral of, okay, vw del u dot product with n vector ds minus integral sign v del dot product with w del u dv, and this is equal to this right hand side but on changing u and v, right? So integral of, okay, writing w as it is and del u is written as del v dot product with del v is written as del u dv. So we have got the second result also. So here ends up the proof of Kelvin's generation of Green's theorem. Okay, thank you.